Today we're going to look at section 3.7 again. So we're going to continue to apply theorems relating the angle measures and the side lengths of triangles. Yesterday we looked at putting them into algebra problems. Today we're going to look at proofs. So I would suggest that you draw this picture, and then we are going to in the end prove that the segment DF and DG are congruent. So let's get started. I'm going to put down my first given, that angle E is congruent to angle H. And I'm going to mark that in my picture. So angle E, angle H, get the same marks. I'm going to move on to my next statement. I know that the segment EF is congruent to the segment HG. And then I'm going to mark that. So EF, HG. All right, so that's all that's given to us. Like I said, we want to try to prove that the segment DF and DG are congruent. So there are quite a few triangles in this picture. We're going to have to prove congruent triangles. It might be a good idea if I know that, if I want to have this side of DF, well, based off of everything that's marked, then that means we're probably going to want to focus on this triangle of DEF. If I want to have this side of DG marked, because that's what I'm trying to conclude, well, look at all the markings. I'm going to want to focus on this triangle of DHG. So those two outside triangles are what we want to get congruent. And right now, we already have 2 out of the 3 things. So we just need to find a third thing. Like I mentioned, there are quite a few triangles in this picture. And the biggest triangle that we have is the triangle of DEH. And in this really big triangle, angle E and angle H are congruent. So we talked about 2 theorems yesterday, and we talked about the fact that there is a relationship between sides and angles of triangles. So in this, I'm giving us that 2 angles are congruent, which if we think back to our theorems, that means that we're actually going to be able to get 2 sides congruent. And it's the 2 sides that are opposite those angles. So I did have to look at the overall big picture. Even though there were a lot of triangles inside, if I can look at one triangle and I see that there are 2 angles that are marked, that means that the 2 sides directly across from them are congruent. So that means that we can say that the segment DE is congruent to the segment DH, and it's going to be that theorem that if the 2 angles are congruent, then that means that the 2 sides directly across from them are congruent. So then if I marked that in my picture, I now can see with the 2 triangles that we have highlighted, I now have 3 things that are marked in the picture. So that means my 4th step, I can state that I have congruent triangles. So triangle DEF is congruent to the triangle of DHG. And if we follow the marks, it's because of side, angle, side. So notice that my first set of congruent sides in the proof came from step 2. My congruent angles from step 1, and then step 3 got me my other sides. And now that I have congruent triangles, any other pieces of those triangles are congruent. So we can go to our conclusion. We can say that the segment DF is congruent to the segment DG, and this is because corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. Let's take a look at another one. So I would suggest that you draw the picture. All right, so hopefully you drew the picture. I'm going to write down the first given. I am being told that the segment LP bisects the angle of NLM. Now, that given is a vocab word, bisect. That means we are going to not move on to the next given. We are going to define what bisect is, we're going to have now a second step based off that first given. So the fact is we are bisecting an angle, and if you look, that vertex is L. So that means that we should have two smaller congruent angle L's. So I'm going to state that the angle NLP is congruent to the angle MLP. And that's because if a segment bisects an angle, then it divides the angle into two congruent angles. And I'm going to mark it in my picture. Okay, so that one vocab word allowed us to expand on it. So once I have that, I can move on to my next given, that the segment LN is congruent to the segment LM. So I'm going to mark that. All right, so notice that we're run out of givens, but we're trying to prove that the segment NP and MP, these two bottom segments over here, that those are congruent. Okay, so once again, that means that we want to try to get congruent triangles. And there's actually several different ways for us to get congruent triangles in this picture. I'm going to have us use the theorems that we are practicing at this time, but there are, like I said, several different ways for us to get congruent triangles. But notice that even though there are two triangles that I want to get congruent, there's technically three triangles in this picture. So if I'm looking at the really big triangle of triangle NLM, I was told that LN and LM are congruent. So I'm giving you two sides. Remember, in a big triangle, if two sides are congruent, then the angles directly across from them are congruent. So I'm going to say that angle N is congruent to angle M. And that's because if the sides are congruent, then the angles directly across from them are. And so then I'm going to mark that in my picture. And so now hopefully we see that that's enough to give us triangles congruent. So the triangle of NLP is congruent to the triangle MLP, and that is going to be because of angle, side, angle. So my first set of congruent angles came from step 2. Then my sides came from step 3. My other angles came from step 4. Now, if you aren't using this theorem, you could have just said that segment LP is congruent to itself by the reflexive property, and then we would have had congruent triangles by side, angle, side. So that's why I'm saying there's several different ways. Now that we're starting to build our repertoire of all of these different theorems, you're going to be able to pick maybe different pieces, and so you're going to be able to get triangles congruent in multiple ways. But once I've stated that I have congruent triangles, now any other pieces of those triangles are congruent. So I can go to my conclusion that the segment NP and MP are congruent. And remember, that's because corresponding parts of congruent triangles are congruent. All right, let's take a look at this one. This is not a proof, this is an algebra problem, because notice it's asking us to find the measure of an angle. So we're going to be calculating here. But what I'm given is that triangle ABC is isosceles. I should also kind of tell you what the base is. The base is going to be the base CB. Okay, so if I have an isosceles triangle, that means we have at least two sides congruent. And so if I'm telling you that CB is the base, that means that it's the side AC and AB that are congruent. All right, and so if those two are congruent, that means that the two angles directly across from them are congruent. All right, so I'm going to mark in my picture. I know that angle 1 is represented as 5x, and angle 2 is represented as 2x plus 12. We want to find the measure of angle 3. Because I don't have what that expression is, we can't do anything right away with that. I'm going to have to find x. And the only two expressions that I have are angles that are actually right next to each other. Notice that those two angles, they're supplementary. They form a straight angle. So that means I'm going to add those two angles, and I'm going to set it equal to 180. So now I'm going to add my like terms. 2x and 5x is 7x. We still have plus 12 equals 180. I'm going to subtract 12 from both sides. That gives us 7x to be 168. And then I'm going to divide by 7. And so that tells us that the value of x is 24. Not my answer, but I needed to find x. Because now that I know what x is, I can figure out what the measures of the angles are that I have marked inside of my triangle. Angle 2. Let's find the measure of angle 2. The measure of angle 2 is 2 times now 24 plus 12. Well, 2 times 24 is going to give us 48. And then 48 plus 12 is going to give us 60 degrees. Now, because angle 2 is 60, that means that this angle ACB, this is 60. If I want to find the measure of angle 3, hopefully we notice that angle ACB and angle 3, those are vertical angles, and vertical angles are congruent. So the measure of angle 3 then also turns out to be 60 degrees. So that's us applying theorems relating to the angle measures and side lengths of triangles.